Assalamu alaikum. Today, me and my friends, we will be demonstrating our final project, which is rented system. So basically, as we can see right now, these are the five members of the project. So let's continue to the problem statement. Now we are on the problem statement. The problem statement, it will show us why we have implemented this system and why we have think about it to make it especially this type of system. So as we know, nowadays many property rental businesses still rely on outdated or semi-manual systems. I mean, they are too retro this kind of system, especially if you want to manage them day by day. So as a result, this will be leading to an issues with our data, such as a lack of transparency and difficulty in tracking the rent and any financial payment. And the tenant also has a problem, which is the limited access to the systems. So, and he can't see the real time information. And moreover, the employee are struggling with managing the records manually. So, in this system will solve this problem and will enhance the old system by automating many tasks for the employee, and it will assist the tenant to see his records by himself and see his payments by himself and control the contract by himself. And this is which will be a big step in the property rental systems world. So now let's discuss the scope of the project. What I mean by saying the scope. The scope is the limit for our project. The project, who's the specific user for this kind of project. So in this project, we decided to separate the features for each user. For example, the tenant has many features such registration, login, paying his own rent, and to explore between different properties. Moreover, we get the employee who can manage the tenant, the payments, even the contracts, and we have the report generation part, which consists of two types of generations of report. First type is financial, and the other is operational. So the technology stack in this project was C++ using database MySQL, and the data security and validation, it uses a basic user authentication and logic to prevent data conflict, hoping to enhance it in the future. So now we will be moving to the functional and non-functional requirement with my friends.
Now I will explain functional requirements. This table lists the top five functional needs for a property system. Number one, role access. FR005 set roles like tenant, manager, admin for security. Payment FR0145 let tenants buy rent online. Number three, money tenants. FR024 tenants report problems with photos. Number four, less raw tools. FR032 use ready templates for rental contracts. Number five, to FR001 protect admin and manager accounts. And now we have now in functional requirements. This table shows the top five noun functional requirements needs for the system. Number one, availability. NFR 01899.9%. Uptime to keep servers running. Number two, encryption. NFR 030 protects data using TLS 1.2. Number three, speed. NFR 01 loads peaks in under 1.5 seconds. Number four, CI and DSS. NFR 059 secures credit card payment. Number five, user load. NFR 008 handles 5,000 users with low errors.
Next, we have use case diagram. This use case diagram shows the rent easy system. Admins can log in, manage properties, tenants, contracts, and generate reports. User can also log in, view properties, and pay rent. It clearly shows the different roles and their interaction with the system. Next, we have the state diagram. This is a diagram that shows what happens when a user tries to log in. It shows the different steps a user goes through, starting with opening the login page and typing in their username and password. Depending on what the user does, like leaving the fields empty or typing the wrong password, the system responds differently. It might choose error message or let the user in and take them to the home page. If the user click forget password, there is a different path. The user is asked to enter their emails, get reset link, sets a new password, and then goes back to the login screen. This diagram shows the login and password recovery flow, checking login details, handle errors, and resetting password if needed, then guided the user back to the login or the home page. This diagram shows how reports are created. User select filters, generate the report, and either see results, an error, or no data message. They can then download or print the report. This diagram shows how tenants can add, edit, or delete. The system checks for missing info or active contracts to ensure records stay accurate and up to the date. This diagram shows how users add, edit, renew, or end contracts. The system checks for missing info or active contracts to keep records accurate and prevent duplicates. This diagram shows how tenants view properties, searching, filtering, and seeing detail like rent and history. If no properties are found, a message is shown. This diagram shows how tenant pay rent, selecting payment, adding a promo code, and confirming. The system check for valid contracts and show the receipt or error.
Client-server architecture design. As you can see on the client side, we have two interfaces, the admin client and the tenant client, each with their own dashboards and management tools. Requests from the client are handled by application servers through an API gateway, which manages routing and load balancing. The server includes six main services: authorization, proprietary management, tenant management, contract management, payment processing, and report generation. All services communicate with a centralized database that stores shared data like probabilities, tenant, contract, payment, and user account. Let's continue with our database design, ERD design. As you can see, we have five tables: contract, payment, probability, tenant new, and employee. And each of them have his own relationships. Tenant new have relationship with contract using tenant ID, and employee have relationship with contract and payment using employee ID, and contract have relationship with payment using contract ID, and finally we have relationship between contract and property using property ID.
Next, we have the component diagram. This is the component diagram of our real estate management system. The system is divided into three main subsystems. The first one is the property portal. This handles the user activity like searching for properties, logging in, and submitting application. Property management system manages all property related data through the property inventory components. Financial management system manage leases, tenants, and payments using components like lease management, manager, and payment processor. These subsystems communicate through interfaces to share data like property info or lease updates. This model structure makes the system easier to understand, develop, and maintain. The last one, we have the class diagram. This is the class diagram. At the center we have the user class, which is inherited by two classes, tenant and admin. First one, the tenants can search for properties, make payments, sign contracts, and view their payment or contract history. The admin have full control. They can add, edit, delete property, and create contracts, manage tenants. We also have the other key classes like property store that stores information about the real estate license, and contract represent agreements between tenants and the system. For the payment that handle rent payments and record them. And the last one is the report, allows the admin to generate report for the system analysis. The relationship between the classes show how the user interact with the property contract and payment. This structure keeps the system organized and supports and clear responsibility. Thank you for listening to our presentation.